So, welcome to my talk, Building Lean Spring Boot Applications for the Cloud. I want to make sure that what you're going to see is just like for educational purposes only. So I'm going to show you some benchmarks, some numbers I have done actually in my applications, and will tell you like what kind of optimizations you can do with Spring Boot. So basically I usually say, I show you the stuff Josh Long never shows you, right? He always has these nice Hello World examples. I show you the real things. So, and that's why also I say, please take it with a grain of salt. All the numbers you see, it might look different in your applications. Just be aware of that. And we are responsible humans. We know that we need to measure and benchmark our system ourselves all the time. Okay. Just a short notice about myself. So my name is Patrick Baumgartner. I'm from Switzerland. I do lots of coaching for software development teams. I help them actually like to deploy things faster to production. And besides of the regular things like review, architecture, training and things like that, I also teach at the University of Applied Sciences in Switzerland as well, like software engineering courses. And I'm also heavily involved in the Java ecosystem, in the software development or software crafting community as well. So yeah, you can imagine I do my job already for quite a while. So why this talk? What is actually the problem? Because I like Spring Boot and also the Java ecosystem. And the thing is actually like you have noticed, switching like every 2 years to another technology, that really doesn't help. So actually like we should make the tools better we are using, and we can actually also like save energy and other things and resources in general. So in the end, instead of changing a human being, we should change the technology and the tools we are using. And so that's like what I want to show you here with my talk, that you can actually like change a lot of things, especially in your Spring Boot applications. Great. So let's dive into the topic. So like if you're going to deploy a new application to the cloud, people will go and ask you like how much resources is your application using? So that means like how much virtual CPUs you need, for example, or how much RAM do you need? We usually don't know, right? We would have to run the application, we would have to measure things. They will ask you also things like about storage and also like which technology stack you're going to use. And obviously, the thing is, you usually use the tools you have at hand, you can work with, and I mean, in the end, in IT, you just need time to solve the problem. That's it, right? That's like the only resource which really matters. With basically all the tools we have, we can solve almost all the problems. So actually, we don't know much about the numbers except if we start measuring. So if you think of actually like moving to the cloud, you also would have to take some consideration regarding resources. So for example, certain cloud providers, they are binding the CPUs and the RAM together. So that means like if your application needs a bit more RAM, it might cost you more because you may need to pay additional CPUs. They're not linear scalable with many vendors, so sometimes just a bit more RAM is an issue because you have to pay more also for more CPU. And then on the other hand, if for example you have an application as a container image and you need to ship it over the network, the traffic actually might also cost. And it's not only the time with your deployment cycle, how long it takes that your container image gets to a node where it will be started, it's also sometimes about the traffic you generate, right? And then actually also scalability is another topic. I mean, scalability could be like fast startup, graceful shutdown, so that means like autoscaler. It's about throughput, it's about latency of the application, right? So that's always things we have to keep in mind moving to the cloud, because it might change quite a bit. So my agenda for the talk is actually like, let's have a look at some optimizations you can actually do in your application. So I will introduce you to the Spring Pet Clinic. So that's like our application. We will go and see like where we take the numbers from. And then we create the baseline to compare different optimizations. Then you see optimizations regarding different Java versions, Spring Boot optimizations, application optimizations, other runtimes, And then I also have some conclusions at the end. And of course, I'm going to show you some magic. So the magic is actually like, you're going to start up the Spring Pet Clinic in half the time. You use like 30% less RAM in your application, and even the application answers way faster than just like the default one. And it's actually not much to do, and I'm sure you can take with you about 5 to 10 different takeaways, which you can implement tomorrow at work. So I know that's a high bar I'm setting, but you will see at the end, it's not magic what I'm doing. I'm always doing the things from a developer perspective and not from an infrastructure perspective. Yeah. So what is the Spring Pet Clinic? The Spring Pet Clinic is a demo application which is actually quite nice, and it's a showcase for different technologies. It's simple, it's a CRUD application, it just shows some data of veterinarians and also some customers as well. And obviously it's there to showcase some technology basically. So the pet clinic is also used, for example, from other vendors, but there is also a thing called the pet clinic community. The regular pet clinic is an official Spring project, but the pet clinic community is a community thing. And why I'm showing it to you here is because it's very nice, because if you want to see like how you would build the pet clinic with React or Angular, for example, you can have a look at this. Or if you want to try out HTMX, which seems to be quite fancy these days as well, there is even an implementation of Spring Boot, the Pet Clinic, and HTMX, right? So if you need to have some inspiration how to use Spring Boot with a certain technology, you will find quite a lot of examples here. So go to the GitHub Spring Pet Clinic community organization, and there you will find like many different varieties. But I'm going to tell you, no, we are not using one of those. We are using the original Pet Clinic for our examples here. And that means like it's based on Spring Boot, it uses Caffeine for caching, it uses Thymely for server-side rendering. We use also Spring Data, JPA, for doing the data access. We use H2 as an in-memory database. Yes, I know there is also a variation that you could use MySQL or Postgres, but just like for my setup, H2 as an in-memory database is simpler to use and do the benchmarks with. So that's why I said I'm using H2 here. And then obviously, the power horse in the Spring ecosystem for all the web frameworks, it's Spring MVC. So that's actually like the variation of the Pet Clinic we are going to use, so the original one. Now, obviously, if you're going to do some optimization experiments, you need to specify a baseline. So the baseline is actually on our side, it's first the technology stack. So the technology stack is I build containers because I'm interested in how fast the container starts with Java in there and the Pet Clinic. So I'm using like what Spring Boot delivers you by default. It's basically build packs, right? And then actually you will see I use also as a baseline Java 17, so the latest version of it, Spring Boot in a current version. Yes, I know Spring Boot 3.3 will be out there tomorrow, so I have to update my talk again after today, right? But I will show you the numbers. And if you're curious about like the things I learned even in the meantime from today to tomorrow, you have to see me next week at Spring I.O. because I will also then add some additions which are only possible with Spring Boot 3.3. And then actually like there is in there some test containers, so that means we test against Postgres and MySQL, and we also have some scripts which populate the data into the database for testing purposes only. So that means like this all has an impact on running the build as well. So we are examining on the one side the build time, the startup time, the resource usage, here specifically the RAM, because usually on a CRUD application CPU doesn't matter much, and the Pet Clinic is a CRUD application. Then we also see the image size, and we have a look at the throughput. So that means like how many requests the application can handle. These 5 things are the things we are going to see afterwards also in the comparison. But first, what is build packs? Show your hands if you know about build packs. Just 2 or 3. Okay, build packs is a standard, and it's also part of the Cloud Native Foundation, and there is an implementation of it which is called Paketo. And build packs are used when you use MVN, Spring Boot, column build minus image automatically behind the scenes to create the containers. Paketo is the implementation of it, which actually generates for you the perfect Docker container. And I say perfect Docker container because there are lots of things considered when the container is created. And Paketo is also there in different flavors. So that means you can actually create Docker containers for your Java app, for your Ruby app, for your JavaScript application, and many other things. And even if you have a legacy application, you can wrap it with Paketo into a Docker or OCI compatible container. What I like about the build pack especially is when you start the whole things up, you will see in the logs that there are build packs already. And for me, actually, like the most interesting thing, and I know it's quite small on the slide because it's on the top above the Pack Clinic logo, you will see things, for example, that the amount of CPU is detected, that the CA certs are patched off your JVM you're running the application with. There is a Java memory calculator in there which uses the resources provided to the container and calculates the heap and other things with these -x parameters and so on. And what you just see below the Pet Clinic logo, I think a few lines below, you will see that it's running with a non-privileged user as well. There is a CNB user, which is not a root user. And usually when you copy and paste a Docker file from the internet, you will run your Java application with a root user, which is really, really bad, and you should not do. So build packs actually do quite a lot of things for you in the right way. And that's why I'm saying actually build packs are 1,000 times better than your regular Docker file. It's not just because of the layering, it's because of many other things you have to consider when building a OCI compatible container. And the other thing is also it's more secure because the build packs community is maintaining the run image, for example. And if there is an issue in Ubuntu, because Ubuntu is like the default operating system used in such a container, when there is a security issue and Canonical, the company behind Ubuntu, is patching that, it takes about 2 to 3 days and it's already upstream in the build pack. So that means you have always an up-to-date base image for your application when running that in the cloud. Obviously, there might be some other issues you might have, and maybe you are not a fan of Ubuntu, you prefer something else, and I'm showing you afterwards that you can use also, for example, Alpine as a other alternative. So, yes, we are going to do build packs, that's very important. So, we just do it the right way. Now, to get a feeling of our application, when I prepared my talk, I found a project which is called Startup Report by Mathieu. Mathieu just provided a Maven dependency, which you can easily add to your application, and it creates for you a startup report. Basically, it's just exposing all the metrics which are concluded already inside your Spring Boot application, which are done there anyway, and it just shows a nice dashboard on top. So there is not much magic here, actually. But still, it's quite nice because you can see things like this. So you can have a drill down. You see the magnifier with a plus and a minus. You can drill down and see like how long it took for every single Spring Bean to be created. And that means like if you look at the list of the beans, it's really like a tree. And to give you a better example, or like a nicer visible example, it's actually the flame chart here, because the flame chart is the same as the listing above. And you see basically like the tree of the Spring Beans created here, and actually also in the flame graph how long it took. And for me, when I ran this tool the first time, I was quite surprised that Hibernate and Spring Data took quite a while. Obviously, I knew that Hibernate is doing some magic behind the scenes, but I was not aware that it takes about 20% of the time of the Spring Boot application startup just to initialize Hibernate. So I was kind of surprised. Obviously, there need to be other solutions afterwards, and that's definitely a thing which can be optimized, right? I'm not saying we are going to change Hibernate, that's out of scope here, but just like this gives me a feeling like where I might lose some time. Okay, so you don't need a profiler, just add the dependency and you have already kind of a dashboard. Now let's have a look at the benchmarks. And when I do usually benchmarks, I do that on my machine at home. So at home I have a desktop machine because my notebook is not very nice for benchmarking because you would get into thermal throttling very fast. So that's why I have a water-cooled desktop machine at home. Just accidentally, really, it happened. I'm not a gamer. It has RGB in there, but I'm not a gamer. I just bought, instead of a laptop, I bought a desktop computer during the pandemics because I thought I will wait till the next generation of laptops is showing up and we don't know how long the pandemic will actually last. So in the end it turned out for this talk it's perfect because I can have a constant temperature of like 69 degrees of my CPU in my machine like for 12 hours or even more. Just that's like very nice for benchmarking. So in the benchmarks, I look at the Maven build times. I look at the artifact created, so that's basically like the container image size. I look at the startup time. I measure the proper amount of RAM, actually. And thanks to the Quarkus team, they also have a very nice blog post about that, showing how to measure it properly. So what the application uses and not just like the reserved memory, which is reserved for the container. And then I'm using WRK for the benchmarking, which is also a tool which is used quite often in the Spring team. And the version 2 is kind of like an addition because it's a fork, which adds also latency information. That's quite nice. I usually warm up my application, then I run my measurements. And I also do my measurements like with 4 cores. Obviously, I'm aware of that when you put your application to your cloud, you don't have like 4 cores for your app. Because at my customer, we are currently talking about 250 millicores, 100 millicores for the application. But what you will see is actually, and that's like also like the one of the conclusion, is that the 4 cores, it's like the sweet spot. So that's the place where or when the application starts up the fastest. If you have less, there is like a range where it's linear, and then below it's even non-linear. So there is no, there are many reasons like why your application, when you start up in a Kubernetes cluster, it takes you like 2 or 3 minutes. That's very common. And on your machine, it takes you maybe like 5 to 10 seconds, right? So just because of the amount of CPU which is needed in the initialization phase plays there a role. So I do the benchmarking with 4 virtual cores actually. So let's have a look at the phase where we say, let's do the baseline. The baseline is actually like the Spring Boot application, so the pet clinic with Spring Boot, with a Liberica JDK 17.0.11. Have a look at the 0.11 because that's important. And I will tell you in a second why. And we use by default the Java memory calculator, which is built in the build packs, and then I just like do my tests as I explained before. So you see the build time is about 67 seconds. We have about 360 megabyte image size. We have a startup time of like 4.5 seconds. We use about 300 megabyte RAM initially before we do the load testing. We have about almost 2,000 requests per second we get through the application. We have, after the testing, like 470 megabytes RAM used before the garbage collector cleans everything up. And then you see the percentiles as well. So that means like 50% of the requests are within 5 milliseconds. 99.99% of the requests are within 159 milliseconds. So that's like how you need to read my table, basically. Right. So that's like what you see and how long things take. By the way, I usually run 10 runs of the test. I cut off the peaks, so I actually like the lower ends and the higher ends, and then I do an average on the data. So I have the feeling that like most of the runs of the application will be like within that range. So it's not like best case scenario, right? So it's really like I try to average and I try to get the middle ground, which is like very common for a regular application. So if you're going like to Java 21, where I just changed the version and even compile with Java 21, you would actually see that the build time changes slightly. Well, that's not much difference. You have an image size which is bigger because now the JDK21 is also inside the Docker container. You see the startup time, I would call that like roughly the same. So that might be also like a misinterpretation of the data or not enough like runs for the averaging. We have a bit less memory used. We still have the same amount of throughput of requests per second. We have a bit more RAM used, and then you see actually that Java 21 gets better towards the end. So when you look at the 99.99 percentile, you will actually see that it's just like 118 milliseconds for those requests, which is actually quite nice. If you have a look at Java 21, 22 even, you can do that as well. And you will actually realize build time is about the same, image size is also a little bit bigger, startup time is slightly faster, less RAM used, and so on. And you would also see that in the percentiles towards the end, the responses are faster. And actually, I was quite surprised because I'm doing this talk already for a while, and I have tested so many different versions of Java. So the 17.11 really makes a difference. So actually what I learned is upgrading your Java all the time makes sense because there are lots of performance optimizations all the time. So 0.8 or 0.11 really does matter in performance quite a bit. And they're still maintaining 17, they're still maintaining 21 as you see with 21.03, but I guess the 22 disappears soon because there will be the Java 23 release, right? So they don't put effort into JDK 22 anymore. And what I have seen is if there is like the first release of a Java version, like probably in September when we get like Java 23, you will see that the first release is really bad in performance, but then the 01, the 02, the 03 gets better over time. It feels to me like that the teams look afterwards at performance. They just need to get the features out first, right? I don't know that. It's just my assumption, to be clear here, right? But it feels like, and that's what you see with 17.011, it really gets better all the time. So let's play around with some attribute you can add to your Java. So you could say, let's have faster startup while using no verify. And that actually turns off the verifier so that your classes get verified when they are loaded, which is actually in production not a good thing. Your bytecode should be always verified. But you see actually like image size, build time will stay the same because we just changed the Java tool options parameter, which I add here as an environment variable. And then you see startup time improves quite a bit. And then also like the throughput, not the throughput, but basically like the percentiles with the latency actually also gets slightly better. So yeah, but that's something I don't want to do in production. We can also play with other things. We can play with the JIT. So tiered stop at level 1 basically turns on only the C1 compiler, which actually helps us to start up faster, but it's really, really getting bad over time because there is no further improvements afterwards in the bytecode, so no optimizations. And you see it the right way in the 99.99 percentiles, it's really like 18 seconds, right? That's really big numbers. So for startup, it's way faster, but for the latency, it's quite bad. I was also playing around with garbage collectors using different garbage collector like the set garbage collector. And I was surprised that this one, with the current Java 17.011, is not really that bad. So you could say you have like similar data, except for the memory usage, which is actually also clear because the garbage collector is not making pauses longer than 10 milliseconds. So that means in the end, the heap just grows over time if you have a lot of requests going on. And that's what you see with almost a gigabyte of RAM, initial RAM usage after startup, and then also like 1.5 gigs of RAM, just like during the stress test. So what I want to say is, yes, you can use some parameters, but what you have seen is the default parameters provided, and also with this Java memory calculator, they're already very good. So I was kind of surprised. If you want to have a look at more parameters, there is a very nice tool which is called the VM Options Explorer by Chris Who Codes. And he gives you, with the different distributions of Java, an overview what parameters you can provide to the JVM while running. So if you need some inspiration, like deduplicating strings and other things, for example, you can have a look what's provided with your distribution you have. Let's have a look at some optimization from the Spring side. You could say having lazy Spring Beans would help, right? So when you start up your application, not all the Spring Beans are created, only the ones which are used. And what I do here is basically I set with the properties, and I know I'm using environment variables here, but I write it in a properties way because I'm a lazy developer, and it's easier and nicer to read than the screaming snake case. I'm just saying that like all the Spring Beans, inclusive Spring Data and Hibernate, will be initialized lazy. So that should actually like make my startup time faster, but the first request is expensive because it needs to initialize everything else, right? And then I would assume that the data is very similar to like what we have seen before. And you can also see that from the data, they don't differ that much. So, but the startup is fast, but actually like the first request is slow. Now, the thing you don't see in the numbers here, since I use warm up, all the Spring Beans for the last test are afterwards already created, right? So that means, yeah, you don't see anything in the numbers because the Spring Beans are already there for the stress test. If you do lazy Spring Beans, just make sure that everything is fine beforehand. So that means actually like when the Spring Beans are created, while your application is running, they're created with a different thread. Usually, when you do everything at startup time, your main thread is creating the Spring Bean. So that means the application is failing in case of a misconfiguration. If you create the Spring Beans with a worker thread of your Tomcat, so that means actually like you just will see an exception in the logs and your application is not crashing, right? So be aware that you have tested your application thoroughly if you use the lazy properties. There is another idea I came across, is basically like pointing to the location where the config file is. Because Spring Boot uses a algorithm where it tries to get the properties and the YAML files from different locations. So it checks like outside of the application in the folder where you start the Java process. It looks in a config folder on the file system. Then it jumps into the class path, checks like the root class path basically, and then a config package in there as well. So the thing would be using a property saying, there is my configuration, you don't have to look for the other things, would actually also improve the speed a bit. And you see now in the numbers, and we are slightly off here in my test numbers, and that's why also you might get the point that I'm not cheating with the numbers. So I really take the real data without like taking just best cases. I would expect that it's slightly, unnoticeably faster and not like lower as it's shown in the table. But I just wanted also to highlight to you that's something which just like where you can save a few milliseconds here. Okay, so there is another thing actually. If you're brave enough, don't use actuators. I'm not saying you should not use them, but if you don't need them, don't use it because they create overhead. And the fun fact is actually like that the pet clinic has with actuators 447 Spring Beans in there. And if you remove them, you only have 275 Spring Beans. It's roughly 170 Spring Beans difference, right? So obviously that will save some times during startup, obviously, but also afterwards, all the metrics which are collected are not collected if you have not an actuator in there. So actually your numbers get better over time, right? And also that's like what you see with the percentiles. They are also, yeah, at the end they're better, but yeah, they are like more or less similar. But you see it also actually like here with RAM usage, for example. Okay, so these are some things you can actually tweak, of course. Then actually like there is a question, what could you optimize in your application? And I'm not going to talk about caching. I'm not going to talk about how to use JPA the right way. I'm not going to talk about like how you connect to external systems and things like that, because that's very much specific to your application. And what you will see here is just like the thing I like to say when I also do Spring trainings, I say starters are meant to start your project and not to end with. So it's very nice to pull in some starters like start the web and other things to your Spring Boot application, but you might have dependencies in there which are not used at all. And so the question is like how you find out that your application is not using a YAML file, it's just using properties, because then you can get rid of the snake YAML parser. Or another thing which you typically have when you have to start the web, there is a dependency for Tomcat with a WebSocket implementation in there. If you don't need WebSocket, you can get rid of that, right? If you don't need checksum, you can get rid of that, and so on and so forth. So the Spring team does a very good job. They say, you're going to probably implement a single page application. You're going probably to have like REST services in your application and things like that. So that's why or how we created these starters for you. So these are usually a good point to start with. But then afterwards, we have to clean up, right? And that's why I came across a project which is called the DepClean Maven plugin. And the DepClean project is a thing from a Swedish university. They actually like built that tool with some companies from the industry, and it checks actually like the bytecode. It checks reflection, so strings in your bytecode basically, and other things. And it creates for you a report where you can see the direct dependencies, the transitive dependencies. It even tells you like things you might probably not use, because for example in the pet clinic web jars are used, right? So web jars don't have a dependency in Java code, just in HTML, and also just behind the scenes. So it would say probably you're not using the web jars at all, right? There are other things like, for example, Hibernate. It will recognize that Hibernate, for example, is not used because Hibernate uses a different mechanism, or like your application uses a mechanism to load the JPA provider via an indirect way, and it cannot find that way. So the tool is not super smart, but it gives you hints, and with your understanding as a software developer, and if you know your tools, you probably know, yes, we still need Hibernate. So that's kind of a false positive. It can also not deal with other things like component scanning or entity scanning. It's not aware of auto-configuration loading mechanism from Spring Boot. It cannot deal with the Spring XML or the Web XML files. So that's a thing you still have to consider. But it gives you an idea, and in my case, I was actually able to reduce my footprint of the application by 5 megabytes. I know that's not a lot, but you will see in the end, all the small pieces brought together make a huge difference. So yeah, that's the thing. And you also see like you use less initial RAM. We have actually even like better times with the requests. Now let's have a look at something which is also there we can leverage. And in the previous times, like in Spring Boot earlier versions or Spring Framework earlier versions, we always used the Spring Context Indexer. So Spring Context Indexer was a project where we created an index at build time where all the component scanned objects were, right? So that file of the context indexer was loaded from the application context, and component scanning was not needed at all. So they deprecated that for the Spring Boot 3.2 version, and as a replacement is like this ahead of time processing or ahead of time compilation. And the thing is, we're not talking about GraalVM native images yet, but this one will be used for the GraalVM native images though. So what it does is, you just add this execution goal additionally to your Spring Boot application, and it generates behind the scenes some low-level code to register Spring Beans. And it's quite surprising to see. So it will deal with all the profiles, with the component scanning, entity scanning. It deals with conditional annotations, the auto configuration, and it bakes everything in code. So there is no thing to be guessed at runtime. So everything built in code, and you can see actually like in your project in the target folder that Java code was generated for you. It was compiled, and it also was added to the jar in the end. And that's like what you see as well, because it takes a bit longer, in the size of the container image created, because it's a megabyte bigger, so probably not really a megabyte bigger, but it's a bit bigger actually, and so it just like went up that one number. It takes a little bit more time to generate this, but then actually like in the end, you see we use less RAM, and also the numbers are, I don't know what the reason is why they are slightly worse. I guess it has to do with the Java version. So I think actually like Java 21 would be slightly better. But that should actually help not to have more CPU usage needed, because like you execute just code and there is no class path scanning needed at all, right? There is another thing you can actually do to even reduce your container image size, and that's actually JLink. And JLink is meant to write a custom JVM for your application. And I don't want to do these steps and crypt the things myself. I'm just using build packs, you know. And in build packs, it's just like a part in the POM file you're going to add and say, yes, I want to use JLink. And it's going actually to reduce my JVM used for that container. And what I like about that, and that's what you see also below, it's roughly 90 megabytes smaller, the container size at all, because you just need the components which were guessed here from the tool. But I know the guessing a bit better, and you see I go and add the modules myself, I strip out header files and man pages, I strip out the debug stuff and so on, and I can reduce it even more, another 13 megabyte, which is actually kind of cool, right? So you can shrink the things quite a lot. Have I told you I love Spring Boot and build packs? It makes our life so much simpler, right? So you should definitely use it. I was then also playing around with different JVMs. As I told you at the beginning, we will have a look at this. And there is a project like OpenJ9, which was very famous in the times of Java 8 because they had awesome numbers. The numbers just got worse, actually. And what they're powerful in is only actually like memory usage. So they're more performant than the hotspot JVM on the memory side, but actually not on the other numbers, right? So yeah, you might see the container size is slightly smaller, and the RAM usage is definitely better, but the timings, it's not really great. Even if you play around with other things like Quick Start, so Quick Start is something like the C1 JIT compiler, or if you use the virtualized flag, where you say basically like you're running in a virtual environment, not on bare metal, it just like really doesn't look that nice, right? So the question is maybe like why you want that, just because maybe of better memory handling. You might also go like for GraalVM. I'm still not talking about GraalVM native images, just like the GraalVM because it has a better JIT compiler in there. So the GraalVM team is actually talking to the hotspot team, to the JDK team at Oracle, because they want to make the JIT compiler from the GraalVM, where you run the Java code, into the hotspot actually, because it's so much better. And you know, we have inherited already the compiler from the GraalVM in the JDK. So we use already the Graal compiler. Now they want to have the Graal JIT in there as well. So GraalVM is really heavyweight. You see the container image size as well. The build time takes a bit longer as well. And in the end, you see actually like the JIT really makes a difference when you look at the throughput, basically like the percentiles. That means like the response times of the application. So that's really a great thing. Yeah, so I don't care about the throughput, that it's slightly slower. So memory usage is also better, right? So if you don't care about the container image size, why not to use the GraalVM? This is actually the numbers for the community edition. If you go Oracle GraalVM, which you can use free in production, because they have this enterprise version like rebranded to GraalVM free, you can use that in production without paying anything. It's even better. So the JIT is better, and many things are better if you use this version actually. And that's also like the thing for native images as well. So I would suggest always to use the Oracle version because it's more performant. And what you would get actually like from other vendors like Red Hat, Bellsoft and so on, they can only work with the community edition, which is open source. The Oracle one is not open source, and all those features which are awesome, just Oracle has them. Another idea is actually using another builder and not using Ubuntu underneath. So Bellsoft released like about a year ago their own builder where they actually use an alpine image. They call it alpaquita. These are the nice little things, so it's like a small alpaca, right? And what they do is they can reduce it even more. So the Alpine Linux, which is used underneath, is really, really tiny. And you see a muscle version and a glibc version of it, because you can choose Bellsoft, Liberica, also the Java version you use in IntelliJ, for example. They also use that one. They have like these two flavors and you can choose from. glibc is more hacky, more performant, but it's a little bit bigger. The muscle one is actually smaller but more secure. Means like, yeah, the numbers actually on the muscle one are slightly worse than the one on the glibc side, except of the container image size. There is a bad point to that. It only works with Java 17. So the guys didn't update that for a year, and I'm in touch with them actually like to fix it. Therefore, for Java 21, I try to find other solutions to actually reduce the container image size or even the run image size actually. And usually you have the base image from Chami. So that means actually you have an Ubuntu with a lot of features in there, but actually you can also use the tiniest one they have. And it even works with Java. And so that means like you can reduce in Java 21 even that part in the container you don't need for your Spring Boot application. Obviously, there might be some features missing you have in the base run image, but the tiny image is also used by a lot of companies because it's really, really smaller. So I'll wait for the moment until Bellsoft is going to fix this so I can change that to the Bellsoft builder again. Now let's talk about GraalVM native images. And obviously you have learned about that technology in various conference talks, and I'm not going to elaborate that too much, but I just wanted to show you that the build time actually like is way bigger than what we have with Java. But obviously we are going to move, or we are going to shift actually like the energy consumption from production to build time. So native images are not really greener. If you deploy often, you spend quite a lot of energy in the build time, and that means you just shift the energy consumed from production to build time, right? And here you also see the differences between GraalVM native images with Community Edition and also the Oracle version, right? So you see now, Oracle version is even way better. So it's really worth it to do that. And you see also from the numbers, when you really have load on your application, GraalVM native images is not that good than your regular Java application. I think that's quite a surprise, right? Okay, let's talk about virtual threads. So virtual threads is a thing you definitely should enable by default if you use Java 21, because it's more lightweight and you get more throughput in your application. So yeah, one request more, that doesn't count much, but you see the timings are way better. So in a Spring Boot app, when you're using Java 21, you definitely should enable the flag Spring threads virtual enabled equals true to use virtual threads, and auto configuration will do the virtual threads for your Tomcat you're using for your embedded Tomcat automatically the right way. I think that's a no-brainer to do always if you're on Java 21. So let's summarize my talk. We have seen quite a few optimizations, and we have gone through all of them actually, and it's quite a list. And you saw it's not much to do actually, right? So it's just a few properties, changing the POM file and so on, so you can easily add that to your project. While actually working on this whole presentation, I came across that topic I mentioned at the beginning, that the 4 cores is really like the sweet spot. If you reduce the 4 cores to 2 cores, it's kind of linear, you know, with the startup times, for example. But then if you go even below that, it's becoming non-linear, so it's getting worse. Maybe you can deal with that, but if your application needs to start fast, use GraalVM native images or use more CPUs for the startup phase, right? Also, throughput is a topic which you have to check yourself in your application. So I just gave you a direction in which one it could go, right? So do benchmarks on your own if the throughput or latency is a problem in your application. There are also other runtimes. There are even runtimes where you actually pay for it. So sometimes it makes sense actually to pay extra for certain things. So you have some enterprise edition, you have like some really things you pay for because these kind of features do not exist. Or for example, like there are distributions where you still can run Java on ARM, which is still supported, but the OpenJDK doesn't, for example, and other things. So there is like companies like Azul or Bellsoft which do that for you, right? And then obviously there are a lot of other ideas I came across with. So crack would be a nice topic to investigate, but there is no build pack for that. I mean, I have done that in a Docker file manually. It looks incredibly awesome. Only works on a proper Linux machine. So Mac OS and Windows or Windows and WSL doesn't work. App CDS actually, so that means class data sharing is a thing. So that's a thing or a topic which becomes nice actually like in Spring Boot 3.3, so released by tomorrow. Then also like I have been playing around with an obfuscator, didn't help much because of the component scanning and so on. I had to make sure that the names always stay stable, that's a huge problem. So another thing I could do is like importing auto configuration manually. So that could also like give some benefits. You can also use like Spring Foo where you functionally create Spring Beans. And then also like some more JVM tuning and so on would be possible as well, right? And there is another project popping up which is called Project Laden, which is in the Java world another idea to make Java applications starting faster. So let's have a look at some optimizations applied. And that's like my summary basically of the talk. Think of this. You are cleaning up your application. You use another builder, use JLink, you add JVM parameters, you use Spring AOT, use lazy Spring Beans, you do the fixation of the configuration location, and you use virtual threads. So if you do this all at once, you will see that in the Java 17, obviously without virtual threads, because that's not possible yet. So you see like the image size with the Bellsoft builder really gets very, very tiny. It's even more than half of the reduction, right? You see the startup time, which is also like about half. The memory consumption is way, way better. So the 30% was not a lie I told you at the beginning, right? And we even got better timings at the end. So it's really, really nice. If you look at this on Java 21 with the tiny builder, because Bellsoft doesn't have it yet, right? And virtual threads enabled, you will see actually like similar things. Startup times even got better. Memory is like it's also not that good like the Bellsoft one, but just like still, I would say like roughly 30%. And then also like with the timings, you get also way, way better. And you saw that in my talk, just a few optimizations we just did here, a few of them, and it's not much, you can get way, way better results for your application. And if you deploy that to the cloud, obviously, yes, it's not maybe green, but it's already a step towards the right direction. So I would love to conclude my talk. My question to you is, did I miss something? Should I know or add something to the presentation? Because for me, this kind of presentation was a huge learning experience, and I'm going to add definitely like more and more to this talk. So talk to me in the break, or maybe you have a question, so please let me know. And I'm here for discussion. Thank you.